Hello everyone, my name is Rubin. I'm part of the Technical Assistance team of Asia Pacific University, and today I wanted to introduce to you guys something known as TOR. Now, what is TOR? TOR originally was an acronym for the Onion Router, TOR. Now it's just called TOR. It is a volunteer-based project consisting of a network of servers to provide anonymity, privacy, and security by using what is known as the onion routing technique. Currently, in the entire world, the Tor network has over 7,000 servers, which is known as relays or nodes. Now, if you haven't known this already, data packets traveling through the internet consists of a header, which contains information such as your IP, the protocol it's using, as well as a payload, which is the data itself. These data packets are actually extremely susceptible to traffic analysis. Traffic analysis can be done by parties ranging from governments to ISPs, your internet service providers, to third-party interceptors, which is a nice term for hackers basically. Now, Tor protects its users by distributing layers of encrypted data packets over multiple different servers on its network before sending it to its real destination. How does it do it? So now, imagine a client, in this case Alice, wants to connect to a server named Bob through the Tor network. First, the client will have to obtain a list of relays from the directory server, and then the client can incrementally create random circuits which are encrypted connections through multiple relays to its destinations. Once it has a list of relays, like I said, it will randomly create a circuit, and it will extend encrypted connections through the circuit before the data actually reaches the destination. Here you can see Alice extends it to this Tor node and then extends it to the second one here, to the third one here before the data reaches the server Bob. Now, Tor works in such a way that no relay in the circuit would know its position in the circuit rather other than the exit node itself. The exit node is an exception because the exit node is used to communicate directly with the destination server. So yeah, the exit node will know that it's an exit node, but the exit node would not actually be able to know where the data is coming from and where it's sending to because of the way Tor works. So here I've made a very simplified version of how Tor actually works. And believe me, this is really a very simplified version. So first, let's get this. So first, the client will handshake with the entry node R1 and get a forwards key and backwards key, and these are used to encrypt and decrypt data to and from the entry node. Then it sends an extend instruction, which is encrypted by the forwards key to the entry node, which then is interpreted by the entry node to handshake with the middle node and get the forwards key and backwards key from the middle node, and then sends it back to the client itself. Now this is repeated for the exit node as well, and once the forwards key and backwards key from the exit node reaches the client can now communicate with the server detonated by the letter S. Now, when it wants to send data to the server, which is here, the client actually will encrypt the data layer by layer using the 3 forwards key that it has gotten from the nodes. So here the inner one is the third forward key, the second forward key, and first forward key. So it's encrypted 3 times. Now, this whole thing is sent to the entry node, which decrypts the first layer, then it sends to the middle node, which decrypts the second layer, then it sends to the third node, which decrypts the last layer. And then the exit node and the server can now communicate. Once it gets the reply, it's sent back. The exit node encrypts it 1 layer, then it sends to the middle node encrypts another layer, and it sends to the entry node, which encrypts it another layer, sending it back to the client. So now the client receives yet another onion-like data with layers of encryption, and it can now use the backwards key to decrypt all this to get the actual reply itself. So like I said, onion-like. With how Tor works, it actually provides an onion-like encryption, hence the name onion router, with the actual data in the middle and encrypted 3 times by default with 3 different encryptions. So in order to make Tor safer, Whenever the client visits another site, or even every 10 minutes, a random circuit is generated by the client. Therefore, the client, when it wants to visit another site or every 10 minutes, it will actually use different relays on the network itself. So no one will be able to pinpoint the activities of the client to which list of servers. Now, I know some of you might be wondering what's the difference between Tor versus a VPN, a virtual private network. So, firstly, Tor is actually more secure than a VPN. VPN providers actually know your IP and the destination IP, and they operate based on users' trust itself. You have to trust the VPN to not give out this information to third parties, and nothing is stopping them. Actually, there's nothing you can do to stop them from actually giving out this information one day. But this is different from Tor, which is actually built for anonymity and security. And the way Tor works, each relay will actually only know the IP of the server behind it and in front of it in the circuit itself. And it is highly unlikely for an individual relay in the circuit to find out the whole circuit, which um, starts from the client to the destination server. Another difference between Tor and VPN is that VPN is considered much faster than Tor. As I said before this, Tor is actually volunteer based, which means each relay is hosted by a volunteer. So your bandwidth is really limited by the relays that you randomly selected. So let's say you're so unlucky that you got a relay with a very bad internet speed. Then your bandwidth is really limited by that one relay. The last example I'll give is that Tor is free. It's absolutely free of charge, at least at this point of time. Most VPN providers, at least credible VPN providers, require a monthly fee before you can use their services. Now let's talk about some Tor-based applications. Firstly, there is the Tor browser, which is a Firefox-based browser that allows users to connect through the Tor network to browse the internet. Another example of Tor-based applications is the hidden services, commonly known as the darknet, which provides anonymity for server hosts instead of clients itself. So if you want to connect to a server that uses the hidden services, rather than connecting directly to the server itself, the client and the server actually meet up at a rendezvous point in the Tor network itself. So the client will not even know where the server is hosted, what IP the server is using, and this provides this anonymity for server hosts. The last example I'll give of Tor-based applications is Tails OS. So Tails OS is an operating system. It's a Debian-based Linux distribution that sends all network traffic through the Tor network before it sends to the destination. And next, I'll give a demonstration of how Tor actually works. So before I move on to the demonstration of Tor, I just wanted to show you guys real quick what happens when you browse through the internet normally. Here I have Chrome, your everyday internet browser, and here I have Wireshark, which is a network analyzer. It will allow me to see the data packets going to and from my network device, which in this case is my Wi-Fi adapter. So I'll just real quick initialize Wireshark, and let's say I want to go to APU's website, apu.edu.my. So very quickly you can already see that there's a lot of packets going to and from my device. There's a lot of TCP connections, and here we can see there's a data packet with the HTTP protocol, and you can see that it's connecting to the host of www.apu.edu.my, and you can see the IP of both the source and the destination servers. So if someone is analyzing my traffic right now, they can actually see that I'm connected to apu.edu.my. And here's all the packets it's getting. It even got the packet from the live chat system in the APU website over here, which says the host is secure.livecheckinc.com. So all packets that are coming to and from my device can be seen using Wireshark, and it can be seen if someone is doing traffic analysis on me. So this is an example with normal HTTP. So what happens if I connect using HTTPS? So let's say I go to I don't know, login.microsoft. So this is a HTTPS website. What happens is that you will see some TCP and TLS connections. TLS is one of the protocols used for HTTPS. You can see there's a handshake going on. And now if I go down, you will start seeing application data in the info. So this right now is actually encrypted using the handshake of my client and the Microsoft Online servers. So even if I try to open this, everything is completely encrypted and I probably can't see this. So this is by design what HTTPS should be like. It encrypts your data. But the thing with HTTPS is people who are doing network analysis, traffic analysis, can still see who you're talking to, which in this case is the IP 23.100.111, 112.64. So even though people can't see what you're talking about, they can still see who you're talking to, and I'm sure with a quick Google search, people can know that the IP is probably Microsoft's servers. And sometimes this is enough for people to know what you're actually doing on the net. So here you can see the application data of encryption, encrypted application data, and whatnot. So on to Tor. Now I've downloaded and gotten ready Tor browser, the Firefox based browser. Over here you can see, and I'll just initialize Wireshark again. And by running the Tor browser application, it will start connecting to the Tor network, and you will start seeing a lot of packets already coming to and from my device. And all of these are encrypted with TLS, which is what Tor uses as well. It uses the TLS protocol. Yeah, it uses TLS protocol to encrypt its connection. And let's say I want to go to, again, apu.edu.my. So now it's going to connect to this apu.edu.my again. And yeah, it's a bit slow. As I said, Tor is slow because it depends on the bandwidth of the relays. Okay, now it's connected. So a good thing in Tor is that you can actually see the circuit generated by your client. With this button here, you can see that Tor circuit for this side. I'm connecting to a relay in the US with the IP 38. Blah blah blah, and then it connects to the US again, and then it connects to the Netherlands before it connects to the APU server. So from the APU server side, it will actually only see the IP of the exit relay, which is in Netherlands, even though I'm connecting to the relay in the US. So here in the Wireshark, you can also see that if someone is analyzing my traffic, they will only be able to see that I'm just communicating with the entry relay, which is 38.229.70.51. So neat. So if someone actually infiltrates the traffic of my device, if I'm using Tor, they won't be able to see what I'm connecting to and who I'm connecting with. And because everything is encrypted, so they'll have a hard time trying to decrypt this. And everything is encrypted. And yeah, there's a lot. So now if I'm going to APU, you can see, oh yeah, interesting. So I've actually tried testing this before, so that's why the circuit refreshed itself. Now it's going from US to Luxembourg to Sweden. So if I want to go to another site, let's say use the previous example, microsoftonline.com. So now when I go to another site, it will generate a new circuit for me if the relay will load quickly. And yeah, by default, some JavaScript applications are disabled using Tor browser because they've noticed that using JavaScript, people can still exploit the service and get the IP of the client itself. Here you can see I'm connecting to the US, to Switzerland, to Netherlands instead. And if you notice, I'm actually connected to the same entry node. This is actually by design how Tor works, because of how random, how the relays are selected by random, by the laws of probability, there's the very small chance where you might get a circuit, the whole circuit with all the relays actually being infiltrated by some third part, by the same third party. So to prevent this, Tor came up with something known as entry guards, which are kind of like certified entry nodes, where they look into things like their bandwidth and how long this entry node has been up and running, and certify them as entry nodes. So when you connect to Tor, they will try to connect you to an entry node which has a lower chance of um, being infiltrated. Therefore, it will basically lower even more the probability of you having a circuit with all three relays being handled by the same third party. So here, as usual, you can see again all the packets are going to and from the same IP, which is the entry relay, which is good. That's what we want to do. And so this is just me going to normal sites. Using Tor browser, I can also connect to the hidden services sites, which in Tor, it's called onion sites because it's followed by a .onion domain, even though it's not actually a domain. So an interesting thing is Facebook actually has its own hidden services site. It's called Facebook core www.onion. This is actually set up by Facebook themselves, the actual real Facebook. They set this up so that people with censored internet connections like China and whatnot can still use Tor to connect to Facebook. It's kind of like a marketing thing, but it works. So here, if I look at Wireshark, you can still see I'm connecting to the same entry guard. That's fine. People won't know who I'm talking with. And here in the Tor browser interface, you can actually see how it works. With the Tor circuit, you can see that this browser is connected to the entry node, to middle root node in Russia, and to the exit node in Denmark. But then, because we're connecting to an onion site, the rendezvous point is actually with our exit relay, which is in Denmark. And the onion site is actually connecting through the Tor network, through multiple relays, and meeting us here in Denmark, which is with the IP of 176.20.234.102. So by using hidden services, the client, me, can't know exactly where the onion server is hosted. So this provides anonymity for the onion site as well. So that's about it for today. I hope you guys learned something new from this introduction of Tor and Tor browser. My name is Rubin. Until next time, thanks for watching. Bye.